Okay, morning guys. It is 8 o'clock. I am recording and let's get going. I know people will join the session still, but obviously you can do the recording and you can listen to it as well. Okay, so basically this morning going to go through the exam prep and going through one of the mock exams that you would have received. So let's start. And as people join, we can just continue. Okay. So when I start looking at the mock exam, it will be like you will have in your exam as well. So it will start at study unit 1, and it will work through to your last study unit, and there's about 2 questions per study unit that you will get. So that is about 22 questions with an added 3 from somewhere else. First session of your exam will be study units 1 to 6. Second session of your exam will be study units 7 to 11. First part, I think, will be 12 questions. Second part will be 13 questions. So that is how your paper will look like. Okay, so basically, then as we know, the first few questions will be around variables. So the first question that I'm looking from the mock exam is then obviously study unit 1, and you will see that study unit 1 will be basically that question. Then it's a bit of frequency. Then we have another one going into, so there's a 1, 2 on stem and leaf, actually 3 on stem and leaf. And then we go into the probabilities. So let's see if we can get this right. So information on the following variables was gathered amid the COVID-19 global pandemic. Which one of the following statements is incorrect? Okay, so again, when we start looking at these things, remember to check when they ask incorrect and when they ask correct. So incorrect, the medical cost of each patient in rands is a quantitative discrete variable. Okay, so you can basically have my notes on study on chapter 1 with you if you're looking at this one. The medical cost of each patient in rands is a quantitative discrete variable. Let me just admit some more students. Okay, so then the next one is, I haven't said right or wrong yet. Then second, the name of or list of provinces affected by COVID-19 is a qualitative nominal variable. Third one, common COVID-19 symptoms, cough, fever, tiredness, and shortness of breath is a qualitative nominal variable. The number of COVID cases is a quantitative discrete variable. And then the severity of symptoms is a qualitative ordinal variable. Okay, so What will happen in the exam, and that is what I now picked up when I looked at the mock exam, is that the, the order set, so these options are being randomized. And I think that is important for you as well. So what I picked up isn't that the physical question will be different. It can be in session 2 when we look at the Zs and those kind of things, because I know last semester it was. But what I now picked up with more of the definition questions like this one, it's more the orders set that are shuffled or randomized in your exam. Okay, so on this first question, what would you have said is the incorrect one? So let me come from the bottom and say the severity of symptoms, mild, moderate, and severe, is a qualitative ordinal variable, which is right, just because there's order in the severity of the symptoms. The number of confirmed COVID-19 cases is a quantitative discrete variable. So it's 1, 2, 3, 4, 5, 6 cases. So that is correct. Common COVID-19 symptoms, cough, fever, tiredness, and shortness of breath, is a qualitative measurement, which is right. So qualitative is right. Nominal is also right because there's no order in this one. So it's not like here where the severity of symptoms is in order. So that is also right. The name or list of provinces affected by COVID-19 is a qualitative nominal variable. Again, no order in provinces. So that one is correct. So that one must be wrong. So let's just see why. The medical cost of each patient in rands, it's a quantitative discrete variable. Okay, so it is not quantitative, it is continuous. And the reason why continuous, the medical cost of each patient. So we actually don't know what the medical cost is of a patient. It's different if I would have said your medical cost, because then it's one person. But because it is of all the COVID-19 cases, we actually don't know what the different medical cost for each patient will be. So that will be more on a continuous basis. Okay, happy with the first one. So again, just remember in your exam, what I've picked up is that nearly the answer set will be the biggest one that will be randomized. Okay, so there also goes my theory of always picking C as the answer if you don't know, because actually, yeah, it will probably be any number that you can pick. Okay, so let's look at the next set of a mock exam. The number of cases, so they give you the number of cases, and then they're probably going to ask you something around this table. The frequency table shows for provincial breakdowns. Which one of the following statements is incorrect? Okay, so the frequency of northwest. So remember, frequency is worked out, and that is already in chapter 2, so that is quite interesting. So how is frequency worked out? Frequency is basically the value. Okay, so the frequency of Northern Cape is 37, correct. The frequency of Northwest should have been 70, okay, and not 0.45. So frequency should be the full number. When you go into relative frequency, when you start dividing, so here we can see relative frequency of Eastern Cape. So relative frequency of Eastern Cape, where's Eastern Cape? So it would be 1936 divided by 15515, and that would have given us the 0.12. Then the percentage frequency of Mpumalanga. Okay, so how would you do that? Okay, so what I would have done is I look at Mpumalanga, so it is 71 divided by 15515, which gives me 0.004576. I want you to get to the percentage. So then the percentage is times 100. Cool. And you will get that one. And then the last one, the relative frequency of Gauteng is 0.15. So Gauteng, you just say 2329 divided by the 15515, 0.15. Okay, so nearly, again, if you used my table that I created on chapter 2, I did put there like a frequency distribution table with what is frequency, how you calculate relative frequency, cumulative frequency, and cumulative relative frequency. So use that table in the exam as nearly a way of working out this. Okay. Next one, and this one is all around, so the next three actually stem and leaf. And I think that is, so nearly prepare yourself that you will get a stem and leaf in the exam. So which of the following statements is correct? Okay, so here we have the stem and leaf. They tell us the data below shows a stem and leaf diagram of daily confirmed cases during the second week of national lockdown. Use the information to answer questions 3 to 5. Okay. The mean of a daily number of confirmed cases is 70. So we are looking for the correct one. The mode is 70. So let's quickly see. Mode is where there's more than one variable. So there is no mode. So 70 is definitely not the mode. The distribution of daily number of confirmed cases is symmetric. If it was symmetric, it would have looked something like that. And it's not, because here's a bit of a tail or a spike towards the end. So the tail is more to that side. So it's definitely not symmetric. The range of the daily confirmed cases is 70. Sure, there's a lot of 70s. But let's look. So the range would have been 96 minus by 31. So 96 divided by 31, minus 51, minus 51, minus 51 is 65. So that one is also wrong because it should have been 65. The median of a daily number of confirmed cases is 70. So the reason why I left this one out is I don't want to do the calculation yet. just because then I need to add everything together, but we'll do that in any case now. The median of a daily, so we have how many? 1, 2, 3, 4, 5, 6, 7. So if we have 7, the one in the middle, so 3 to that side, 3 to that side. So it is right. So the median is 70, and we're looking for the correct one. So the 70 is the right answer. Let's just work out the mean as well. So we would have needed to add all of these together and divide it by 7. So it would have been 31 plus 43 plus 63 plus 70 plus 80 plus 89 plus 96. So the total, the sum would have been equal to 472, if I worked it out correctly, and that then you need to divide by 7. So the mean would have been 67.43. Okay, but before I even will work that out in the exam, I'll check if one of the other ones that are easier to calculate or to get will not be the answer that I'm looking for. Okay, so let's look at the next one, which is a follow on. So hopefully anything that you needed from here, they would give you. So let's also, again, we're looking for the correct answer. Is it the same stem and leaf, 31, 43? So it's all the same. Consider the stem and leaf diagram again. Which one is correct? Okay, so now again, I'm looking at the easiest ones first. And now, very important again, not like I made the mistake in one of the sessions between position and value. So I think that is nearly how they want to catch you out. So let's look at this. So so we already know that is the median. So that is Q2. Okay, so then there's 3 to that side, 3 to that side. So it nearly feels like somewhere there must be Q1, and that will be nearly Q3, and that will nearly be Q1. So let's just check. The position of a third quartile is 89. Position, so no, the value is 89, so that one is wrong. The position of a first quartile is 43. Position, no, the value is 43. That one is wrong. So again, I think it's because I don't want to first work out the interquartile range. I first want to check for other ones which are easier. The value of a third quartile Q3 is 6. No, that is the position. So that one is also wrong. The value of the first quartile is 2. Again, no, the position is 2. Also wrong. So the interquartile range will be the correct one. But let's see. So it is, remember, interquartile range is Q3 minus Q1. Q3 is 89. Q1 is 43. So 89 minus 43 is equal to 46, which makes that one correct. Okay, so this one nearly, what I did from the start was to say, okay, get my middle, and then nearly it's easier to get the Q1 and Q3, and then very important, and not like I made the mistake in one of our sessions, position value. So every time that they did swap it around here, but I think that is the important thing is nearly in the exam as well. Again, very easy to make that mistake because you are looking at that number and you're like, but it is 89. Forgetting that they're actually asking the position and not the value. Okay, so in this one, they basically, in both of these, they were looking at nearly study unit 3. So let's look at the next one. So still, and now it becomes a bit more tricky. What is the standard deviation of a daily number of confirmed cases? Okay, so what is it? 1, 2, 3, 4, 5, 6, 7. So what I would have done, and now I'm just going to open my Excel, because you can also do it. Let's just, weird that didn't pop up. Okay, so let me quickly, okay, so I would do this calculation in Excel. You can use your calculators as well. You can use, if you can put in data into an online tool, you can do that as well. But for me to work out standard deviation with any formula, I nearly want to skip that because it is really a long process. So I just need to make sure, and I will send this to the group now as well, so that you at least can work with it in the exam. Okay, so let's just quickly, the standard deviation of a daily number of confirmed cases. Okay, so my standard deviation, check if I can quickly, where is my, okay, I need to make it a bit bigger just to, okay, so there I worked it out. Oh, come on. There I worked it out with, I just want to move it a bit. Okay, the standard deviation as 23.77, and there is my answer, 23.77. So the reason why I use standard deviation of a sample, this is not the population, so this was a sample of COVID cases. So it's definitely not the population. If you probably used the population standard deviation, you probably would have gotten the 22.1. So that would have been the 22.1. So just be very careful when you work with this, but this is a sample that we are working with. So I will send you this Excel spreadsheet as well on the WhatsApp group that you can just, so if you need to add variables to it, you can. Let's quickly check if I change it to have it that bigger portion, if it stays the same, yes. Okay, so if that is your variable set, I don't see that they will give you more than 10 numbers. You can basically just change it and get the answer. Okay, please try to avoid using formulas as much as you can. I just hate formulas if you can have access to other tools that can be quicker. Okay, so if you have access to online calculators, normal calculators, apps, anything like that, use it for the exam, please. The only thing you're not allowed to use is, and I will mute the WhatsApp group in any case, but the WhatsApp group or any of, or any person. Okay, so let's just, and please don't use the Telegram groups during the exams, because they are monitored by UNISA as well. Okay, so that was basically looking at your study unit 1, study unit 2, then study unit 3 was actually a bit more questions. So now we're going into study unit 4 with probability. There's 2 questions on probability, and then let's see what the next one will be. But basically 2 questions on the normal probability questions. So let's see. I just want to see if I can make it a bit bigger for you as well. Okay, so which one of the following statements is incorrect? Okay, so they give you probabilities here. So majority of employees working from home during lockdown. A team of mental health experts reported the following probabilities of primary caregivers working from home versus those away from home. So working at home, working away from home, feeling secure, feeling insecure. And the impact is on that secure and insecure on children. Then they ask you a set of options, and which one is incorrect. The probability that a primary caregiver works from home, given that their child is securely attached. Okay, so example, working from home, given securely. Okay, so how would you guys have worked that out? Okay, so let's first need to add a bit of probabilities in here. Okay, so this is one of those that they don't complete, so you need to complete it. Or so when you do this in the exam, because it is online, you need to draw that just on a piece of paper for you to then work out. So the probability that the primary caretaker works from home given their child is, so I would have said it is that primary and home given secure, so it would have been 0.38 divided 0.56. which if I round it off to 2 decimals is equal to 0.68. Okay, so that option is correct. Oh, I'm looking for the incorrect one. Okay, so we need to go to the next one. Okay, so we will work out a few of these types. The probability that the primary caregiver works from home and their child is securely attached. So work from home and securely attached is just that. Okay, so it's already in the probability, so you don't need to, if it was a number, you would have taken that number still divided by the total sample. Here it is already in a probability, and if you tested it nearly, if you divided that by 1, you would still get the 0.38. So that one is purely just reading it off a table. So that is also correct. Still looking for the incorrect one. The probability that the primary caregiver works from home. Okay, so we need to add those two. So it's 0.38 plus 0.15, so 0.53. The other thing that you guys please need to remember, I'm just now thinking of this because I know here's another question around this, is that remember in the exam when you're writing, if you finished with this question and save it and go to next, you will not be able to see this again. So you will not be able to go back to this question at all. So if whenever they tell you a question that is basically 2 questions of the same data, please try to write as much of that down, because it can be that you need some of it for the next question, and you will not be able to go back so that you can look at some of the information. Okay, so let's look at the probability that the primary caregiver works from home. So it is basically working from home, nothing else. It is 0.53. The probability that the primary caregiver works from home or their child is securely or securely attached. Okay, so let's just quickly, probability working from home. Okay, sorry. Let's do that. So probability of securing working from home was 0.53. The probability of being secure was 0.56. Remember, we want the or, so we need to subtract the and. So it is probability of the one plus the probability of the other one minus the and. So that would give me 0.71. Okay, so that one is the incorrect one. So we have the incorrect one. It should be 0.71, but let's look at the last one just so that we nearly have covered all the instances of probability. The probability that a child is securely attached given that their primary caregiver works from home. So securely attached, given that they primarily works from home. So where this one was 0.58 divided by 0.56, this one is just basically doing the opposite. So let's quickly see. Oof, that should be. So let's quickly see if that is the answer. 0.38 divided by 0.53, which gives you 0.72. Okay, so that one is correct. So the one that was incorrect was D. So let's just do the next one and then just have a quick check in with everybody. So again, giving us this table, and it's interesting. Some of the question has 4, some of the questions has 5 answers. So I think there's supposed to be 5 answers to all the questions. We'll just let's check again. Yeah, that's probably a mistake. But if it's only 4, it's easier. So we then won't complain. So okay, so let's look at which one of the following statements is incorrect. The events secure and insecure are complements of each other. The events of home and secure are independent. The events of home and away are mutually exclusive. The events home and insecure are not independent. Okay, so let's first do the easier ones. The events secure and insecure are complements of each other. Yes. So if it's not secure, it is insecure. So that is correct. Then I want to go to a mutually exclusive one. When events home and away are mutually exclusive. So you can't be home and you can't be away. So they are mutually exclusive. So you can't be both. Okay, so that was the easier to identify. The independent, non-dependent, you will need to work out. And that for me is, let's quickly see, is there an easy way to work that out? So you need to say, see, now it would have been nice to have that 0.53. So if that is 0.53, this will be 0.47. That one was 0, what was it? 6656. Okay. 0.56. 0.44. Okay. So remember, for independence, and again, you can go to my notes on study unit 4. That's where I'm also now going. So for independence, so if something is independent, the probability of A and B will be equal to the probability of A times the probability of B. Okay. So what's the probability we're looking here for? Home and secure. So the probability of home is 0.53. The probability of secure is 0.56. So if I multiply that out and it gives me the 0.36, then I know that those two are independent. If it does not give me the answer, then it is okay. So that tells me then that these ones are dependent and not independent. If they were equal to 0.38, they would have been independent. It is not equal to 0.38, so they are dependent. Okay, so B is the wrong one. Let's just do the same with this one. So it would have been home and insecure. So home and insecure. Home again would have been 0.53 times the insecure of 0.44. So 0.53 times 0.44 is 0.23. So that is not equal to 0.15. Thus, we can say it is dependent or it is not independent. So that one is correct. Okay, so basically, what I wanted to do first is get the easier ones out of the way. Then, unfortunately, none of them were the incorrect one. Then you need to work out the dependence and independence. Okay, before we go on to the next one, which I think it's more the discrete, let's do a quick check-in. Everybody okay till now?
Hi, Jean.
Hi, Precious, how are you?
Fine, and you?
Any
Can you?
questions? Yes.
I want to ask this one about mutually exclusive.
Yes.
The mutually exclusive is not if the event are equals to zero.
Yes. So think of mutually exclusive in two ways. So you can work it out as your probability of A and B must be equal to zero.
Yes.
So if you but look at, it's difficult to so in this table you don't have a mutually exclusive for home and away. Oh, sorry, you don't have a probability for home and away. So when you get a table like this, the one thing that you need to remember is you can't be home and away. So you can only fall into one of those. So if I'm asking mutually exclusive about those two, it will always be mutually exclusive. The same
Okay.
if I ask you about secure and insecure. You can't be secure and you can't be insecure. So you can't be both of them. It's nearly, if I look back at this, you can't be in Northern Cape and Northwest at the same time. So they are mutually exclusive. So that's the same nearly how you need to look at these tables. If they are secure and home, then it's a different story, because then there is a probability. But because it's the home and away one, you can't be both.
Okay.
So that's how the mutually exclusive works. Okay, does
Okay, I
that help a
understand.
bit better? Okay, cool.
Yes.
Okay, awesome. Anybody else up until now? Okay, let's go to the next questions. Okay, phew, a lot of writing. Ugh. During level 5 of lockdown, a popular retail bank was operating in only 35% of its branches. Suppose we randomly select 20 of the branches to check whether they are operating not not closed or closed. Which of the following statements is incorrect? Yo. Okay, so the first thing that I want to ask you guys is, what type of distribution are we looking here at? Because that will also determine what we will be using in getting to the answers. So what type of distribution? Okay, great. Binomial. And the reason why binomial is because they're basically saying here to us whether something is operating, so not closed or closed. So you always just have a two option. Is it open or is it closed? Okay, so we're working with binomial. I just want to make it, okay, that didn't work out so nicely. So yeah, let's just use this again. Okay, let me just quickly want to open the door for somebody. So let me quickly, give me 1 minute, please. Okay, I'm back. Okay, so we're working with binomial. So we need to get to a binomial where n is 20 and that pi thingy, whatever that sign is, how you call it, is 0.35. Okay, so I've got my tables with me, and let's see if I can. Okay, so n is 20, so I'm gonna quickly want to copy and paste this out of a okay, so just to show n is 20, I want to work with 35. Okay, so because of that, let's just make this didn't need any all of that. Okay. Okay, now I see the yellow went with. Okay, so the average number of branches operating the level is 7. So remember to work out the mean. It is the formula of n times. So here they're asking actually a few things of the binomial in one question set. So it is n is equal to 20 times 0.35. So let's just 20 times 0.35, and that is equal to 7. Okay, so that is correct. The probability that at most one branch operating during level is 0.0022. Okay, so at most. So what does at most mean?
I think it's greater or equals to.
Okay, so at most is just for opposite. So at least would have been greater or equal to. At most means only nearly. So the probability that at most one branch is open. So it is basically 1 and 0 or 0 and 1. Okay, so I think that is always the difficulty with these at most. Least I hate it when they ask that. They should have just actually said probability smaller or equal to 1. So there can't be two branches open, at most one. Okay, so if we then look at it, we need to say at most, so it is probability. So I'm going to do it here. Probability that x is smaller or equal to 1. So that is probability of 1, which is 0.002 plus the 0, so 0, 0, 0, 0, 2, which then gives you 0, 0, 0, 2, 2, which is that one, so that is correct. Okay, so I think that is, again, the difficulty with some of these ones is nearly in some of the words, because I struggle as well with at most, at least. I always need to read it a few times because that is nearly how they want to catch you out, instead of just saying it in a formula like that. Okay, so let's look at the next one. So I'm just moving so that we can the probability that only one branch operates. So that is only one branch, x equal to 1. So the x equal to 1 was equal to 0, 0,02, 0,002, sorry. So that is also correct because it is just looking at one branch. So that would have been correct as well. The average number of branches closed during is 19. Okay, so this is the trick question. So how do you calculate that? Okay, how would you calculate that? Okay, so we're looking at the average, so the mean. So it's still looking at 20, but what's the probability, or what's the what do we call it? So what will the number be for close, so for not operating? So if it is 0.35 or 35% for operating, and remember it's binomial, so if it's not open, it's closed. So for open, it is 0.35. So then for closed, it is 1 minus 0.35, which gives us 0,65. So remember that 0,65 is 1 minus the 0,35. So we're looking here specifically at closed. And that will then be equal to 0,13. Wait, wow, what did I now do? 20 times 0.65 is 13. I don't know what I now did with a 1.13, but it gives us 13, and they tell us 19. So that is wrong. So D is the wrong one. But let's just look at the last one as well, the probability that at least one branch. Okay, so now it is, so at least one branch, it is the probability of x bigger or equal to 1. So it is basically probability of 1 minus just that that one part when it is 0. So it's 0, 0, 0, 0, 2. So the probability will be 0, 9998. Sure, I'm writing terribly today. Okay, so that one would have also been correct. So just be on the lookout for this one and how you need to calculate it. So because it's binomial, if it's not open, it is closed. So you can then work with the same. If it was the proper or it was 0.35 for open, it is 1 minus 0.35 for when it is closed. Okay. Questions on that? Okay, let's go on to the next one. Let's see what is the... Okay, here they tell us, boys on, which is quite cool. So, foot traffic describes the number of customers entering location of interest upon moving to level 4 of a nation lockdown. Foot traffic at Mall Azania was established to be 20 customers per minute. Okay, so remember that is also equal to your variance. If I then ask it, okay, so we're looking for the incorrect one, and that is equal to mean. So I would nearly, my first things would have been to look for areas, so probability, so we need to look at the table, need to look at the table, need to look at the table. The variance of a number of customers entering Mall Azania is 20, correct. So the mean of a number of customers entering Mall Azania is 20, correct. So basically we already identified two of them because of just writing down. If I know my lambda, I basically know my mean and variance, so I can get those two sorted out. So that is correct. I'm unfortunately looking for the incorrect one, so I will need to go to my table. Let me quickly copy my table out. It is for 20. Let's hope. Let's hope I've got one for 20. Okay, this is, yeah. Oh, okay. So what they just did, they in the one that I have now copied it out of. Okay, I can put it over these two. They've just made it from 0 and then it goes on and on for lambda 20. So we just need to make sure how we work with this one. Okay, so the probability that at most, I hate this, but, but so at most 35 customers will be entering. So at most 35 means 35 or less. So we want to know basically what's the probability of those last four. The probability that at most 35. So how I would have calculated it is to say 1 minus those last four, because I want the rest. And there's no ways in the exam that I will go and add 35 probabilities. There is just no ways at all. And please don't do that. So I know I need to get to all of those. So I would rather say 1 minus these few. So it is 0,004. So it is that plus that will 6, 7, 8. So it will be 1 minus 0,0008. So that one is definitely not right. So the incorrect one is A. But let's look at the probability that 35 customers, so only 35, okay, correct. The probability that 19 customers will enter, 19, correct. Okay, so here it was that we needed to work out what's the probability that at most. So even if you, so what you would have seen is if you said 35 and above, you would have said that is correct, because then it would have been 0,0008 plus 0,0007, which would have given you the 0,0015. Okay, so very important just that which one you would say is correct and incorrect. Okay, so the at most means that the most will be 35, so you won't have 36, 37, 38, or 39. So it is 1 minus those group of individuals. Okay, so in the Poisson, they now, like in the binomial, they've asked you about the variance and the mean so that you know that, and then they've asked you a few probabilities. That is what they will do with a binomial as well. So they ask you a few probabilities, they ask you about the average or the mean, and they could have asked you in here a question about variance as well. But again, on that study unit 5 summary, I did use those information. Keep it next to you. I think that's the easiest to do. Okay, so interesting, they haven't asked a discrete random variable. So maybe expect that in the exam, that they might actually then ask you a question on a discrete random variable. Normally there's one on discrete, one on binomial, one on Poisson. Here there was nothing, so maybe expect a discrete random variable. Okay, so let's look at the next question. The Department of Labor's Unemployment Insurance Fund introduced the coronavirus benefit for employers who cannot afford to pay their employees. Suppose that the amount of payout to the recipient is normally distributed, sure, with a mean and a standard deviation. What is the probability that a random chosen recipient will receive a payout of at least? Okay, so what do we have? So we're going straight into question or study unit 6 in this instance. So X 2460 mean equal to 3730, and your standard deviation, that's a big standard deviation, normally distributed, so we know that it is the population that we are working with. So that is what I need to work out. Let me just, so what is the probability that a random chosen recipient will receive a payment of at least, ugh, I hate this, at least, so at least means that or more, that or more. So the Z that you will then work out, you will need to work out, so when we get to the Z, at least, so it will be more than. Okay, so let's quickly check. X, we've got 2460 minus 3730. So this is going to be something negative divided by that. So 2460 minus 3730 is minus 1270 minus 1270 divided by 1000 is equal to minus 1.27. Sure. Minus 1.27. So I need to get that portion. Okay, so I will go to my negative table where it is minus 1.27. So minus 1.27. Let me just, so minus 1.27. So going down to 1.2 across to 0.7. So it's 0.1020. So that part is 0.1020. Okay, but that's not my answer. So I'm looking for this part. So 1 minus that will give me my answer. So 1 minus 0.1020, which is 0.898. 0.898. Finally, we have C as your option. Okay, so but again, I nearly like to draw this diagram for me so that I can see which area I am looking for, because yes, they do give you the other area as well. So if you made the mistake to say I'm looking for that area, there was an answer for you, unfortunately. Okay, so now they're asking it a bit differently, and I think this was one of those ones that was in one of the assignments as well, that sometimes catches you out. So suppose that z is smaller or equal to So the probability, so let's draw this a bit bigger. I'll delete that one. Or so imagine just that was a normal distribution. Normal distribution, we know Z is where 0, and then the one side is 0.5 and the other side is 0.5. Okay, so here they're asking us, suppose that, so you need to get a Z where the probability is equal to 0.6. Okay, so if that is 0.5, I will need to add another 10%. So then that whole area would be equal to 0.6. So we could go to the table. I'll go to it now. But if that is 0, this number must be bigger than 0. So that number will be bigger than 0. So it can't be that, and it can't be that. So it automatically already cancels two of the negatives because I am looking for a positive value. Then I would go to this, so we know that we're looking for where this value must be equal to 0.6. So that value equal to 0.6 must be in this. So I need to look where it is 0.6. And now you can see there's a 0.6. So it's somewhere in between there. So I'm looking for an answer that is close to 0.26 or 0.25. So when I go back to my answers, I'm looking for an answer, I said, that is close to 0.25 or 0.26. Okay, and when you see that one is actually in the middle of the two, so that is your correct answer. In the exam, they won't give you an option of 0.25 and 0.26, and then you need to, if it's not spot on exactly, they will nearly give you the in between, but they won't go and now have free options of 0.25, 0.255, 0.26. You won't get something like that in the exam, so you don't need to worry about that. And I think that is more the important thing. So what they could have had is, if you worked out 0.4, then that would have probably been the answer. Okay, but otherwise they will not have free options for you that is so close to one another when you're reading something off a table. So that will not happen. Okay. So I've showed a few times now how to use the table as well. So hopefully that will assist in how you need to calculate it in the exam. So basically, up until now, study Unit 6. So let's see if we actually now go into study Unit 7. Just a quick check-in. Everybody's still fine? Any questions on it thus far? I think what for me stood out in this mock exam is that it's not difficult, but you need to think the whole time. Yes, there is a question.
Morning, Tim.
Morning, Ronnie.
Yes. Can you go back to the poison one? That one that was saying at most.
Yes.
I didn't get on that table. How do we go about looking for the values that are above 35?
Okay,
One at
so
most should be less than 35.
Okay, so let's quickly look at that one again. So when I tell you at most, think of it nearly in when I look at these kind of questions, I always try to make it more relative for myself. So it's nearly like, how many hamburgers can I eat? I can eat at most 2 hamburgers. So that tells me I can eat 1 or 2 hamburgers or nothing. So what is the probability that at most 35 customers can go into the shopping mall? So what's the probability that 0, 1, 2, 3, 4, 5, 6, up until 35 customers can go into the shopping mall? So if I needed to work that out, I would have said in normal terms, I would have said, okay, what's the probability of 0 customer is that 1. So I needed to add all of them, all of them, all of them up until 35. So that would have been my answer. But I'm not going to add all of that because that will take me nearly 10 minutes. And then also the probability that I'm making a mistake somewhere in there. But I know, and we all know from all our probabilities, that when you're working with a certain probability, it will always be equal to 1. So I know that all of these probabilities, if I add them together, will give me 1. So then I would rather say to, instead of adding all of them together, well, 1 minus these last 4 will give me that sum of all the other probabilities. And that is nearly why I rather than said 1 minus the sum of those 4 will give me the probabilities, and that is why that one was wrong. Okay, so it is more to say I'm not going to add all of them together because I know if I now need to put this all in a calculator, at some stage, adding 35 probabilities, I will make a mistake. So I will rather say 1 minus. And they won't expect you. So again, in the exam, there won't be something like this where it is 20 and you need to add. So it will be nearly that it's only a few that you need to add. And that's why they nearly wanted to test it here, that you know that 1 minus nearly that small portion will also give you the same answer. Okay, they will not expect you in the exam to add 15 probabilities to get to an answer. And that's why you will see a lot of the times now they've asked you one of those and then the probability of exactly 35. What's the same in the binomial, the probability that only one. They're not going to ask you that somewhere here in the middle, you now need to add 6 or 7 or 8, because again, that just takes time. So I think that is also nearly a indicator that in the exam, they will not ask you to add 15 probabilities together to get to an answer. The exam is so timed that they won't expect that from you. Okay. Does that help?
Thank
Does that?
you.
Okay.
It's clear now. Thank you.
Okay. Awesome. Okay. So let's look at calculate the standard error of the mean. Okay. Then I see that is what I need to do. So standard error of the mean is this. So I'm not even going to look at any of the other things that I'm just looking for. What is my standard deviation and my n? The standard deviation was 1,000. My N is 10,000. So it will be 1,000 divided by, so the square root of that will be 100. So 1,000 divided by 100 will give me 10. Another C finally. Okay, so I'm not even looking at any of the other information that they give me, because that is nearly, they want to confuse me, and I don't want to even know, because if you suddenly used that instead of the 10,000, you will get a different answer. So that is why I looked at what I need to get. I write down my formula that I need to get, and then I just go, okay, standard deviation. Let's read through, and the standard deviation of that. Let's read through, and there's my sample. So that is the information I have, and I get to my answer. I don't actually care what the mean was. I don't care anything about the rest. I just want to answer the standard error. It seems to me that they really like asking the standard error question. I've seen it now in a few papers for the last few semesters. So you can expect one, even two standard errors. So the standard error of the mean, or the standard error of the proportion. So nearly just be prepared for that. And what for me was interesting is that is nearly what they ask on sampling distribution. So they've asked you about the Z and the inter, or the Z and how to calculate Z nearly in study unit 6. Study unit 7, a big focus on standard errors. So I would, just to prepare for the exam, just look at the other standard error of a proportion as well, that you know how to do that. Okay, so let's go into the next one. A sample size of N7. Okay, so we going to work confidence interval. Okay, so when I look at confidence interval, I need to make sure if my standard deviation is known or not, so that I can know if I need to work with a Z or with a T. Sample standard deviation, so that tells me I'm working with a T. Okay, so then my formula for that is so we need to go and work out the degrees of freedom. We need to look at the alpha divided by 2 times standard deviation divided by n. So let's quickly, I just want to open up my table as well, so that I can get to the t. Okay, so let's just close it again. So I need to look for the t. So the degrees of freedom is 70 minus 1, so that was my sample size. So 70 minus 1 is 69. 95% confidence interval, so 0.05 is my alpha, but divided by 2, so that gives me 69, and for alpha is 0.025. So that is my t that I am going to look for. So let's see what that is. So 69 and 0.025. So 69, 69, 69. Okay, so there's my 69. Go across 0.025, 0.025. Got it. Okay, 0,025. So where those two cross, 1,9949. So I just need to remember 1,9949 multiplied by the sample standard deviation of 1,000 divided by square root of n. Okay, so that is going to be a weird number, plus minus the sample of 3,750. Okay, so I just want to check, so it needs to be somewhere in the middle. So that nearly all seems fine. Okay, so I couldn't even eliminate anything there. So let's see, now calculator. So 1,000 divided by the square root of 70. I get 119.5229. So if I multiply that by 1.9949, I get 238.4362. We can later on just round off, as I now see they've rounded it off to the nearest full number. So basically 3730 minus 238 gives me 3492. Okay, so none of our other does. And then if I say 3730 plus 3730 plus with 238, I get 3968. Okay, so that would have been the answer I'm looking for. Okay, but here we needed to, I think the important thing is identify, because it's a sample standard deviation, the population standard deviation is unknown. Because it is unknown, we're working with a t. And then we need to understand again how we calculate the t value. So the degrees of freedom is n minus 1. So that would have been 70 minus 1. For alpha is the 0,5 divided by 2. So the t that we worked out was 1, let me just write it down here as well. Okay. So now they've asked you the t, so the chances that you will get another t in the exam, if they've asked you it once, is very slim. So what they then will probably do is, if I ask you another confidence interval, it will probably be on proportion. So nearly before I even looked at this one, it nearly says to me it's going to be a proportion, because then you are going to work out a z in any case. So let's look at the information. A study of 200. Yes, Precious.
Can you please go to the one that we were doing now?
Yes.
Can you please explain when you said we are going to use the one with T? How did you know that one?
Okay, so remember, when we're working with confidence interval, there's 3 types of confidence intervals that we can work with. So the one is, if you know the population standard deviation. So if a population standard deviation is known, we work with a z.
Okay.
If it is not known, we work with a T. And I think what is important is population standard deviation, because sometimes we say, but you're working with an unknown standard deviation. But when you look at this and you say, but John, why are you saying unknown if there's actually, you're telling me it's 1,000? So I actually know it. So what we actually need to look at is, if it tells me sample standard deviation, then we are working with a T. It needs to tell me population standard deviation that I can work with a Z. So that is the one that you nearly identify it. So also, if they say in the exam, they can say in the exam, something is normally distributed, like they did here as one, and said sample. So the whole time they're talking about sample mean, sample size, sample standard deviation, then you know it's a T. Seldom will they tell you that you have a sample mean but a population standard deviation. So that will also not happen. So they nearly need to, in the question, say if it is population that you're working with or if it is the sample that you're working with. Okay, does that help a bit?
Yes, it does. It does. Thanks.
Okay, cool. No
All
problem
right.
at all. Okay, so this question we're looking at, I think it's proportions, but let's first make 100% sure. A study of 200 commercial landlords show that 80 of them reduced their rental rates during lockdown. So 80 of the 200 reduced their rates. Construct a 99% confidence interval estimate for the population proportion of landlords with reduced rental rates. Okay, so I think it's important here they tell you 80 of them reduced, so 80 divided by 200 gives me 0.4. Okay, so now we need to go to that formula that says P plus minus, so it's still part of that one page on study unit 8 that I have created. We get to the Z now, so don't worry about the Z now, we'll get to that now, but let's first get the other part sorted out. So it's P times 1 minus B over N. Okay, so that is going to be the formula. So it's going to be 0.4 plus minus, the Z we're still going to calculate now, 0.4 times 0.6 divided by 200 and the square root of that. Okay, so let's go through options. So because it's 0.4, my lower one must be less than that. So this can't be an option, and that can't be an option. Okay, because that is going to be in the middle. So this one needs to be, the lower one will need to be less than that. 0.75 is not, and 0.73 is also not. So that tells me already I can eliminate those two. Okay, so the Z that we are working with, 99% confidence interval. So in your study guide, there's that table, and in the notes I made as well, that says what is 90%, what's 95%, what is, so 90, 95, 99%. So for a two-tail, and we're working with confidence interval, so the Z is always two-tail. The 99% confidence interval Z that I'm going to use is 2,58. So that is out of that table. That so you can have a marker nearly pasted in your study guide for that table, or you can use my study unit 8 summary as well, and that is standard, that you can, whenever they say 99% confidence interval, we use the 2.56 when it is proportion or when the population standard deviation is known. Okay, so I'm first now working out this part. So 0.5 times 0.6 gives me 0.24. If I divide that by 200, I get 0.0012. If I then take the square root of that, I get 0.03464. So I hate it when stuff are not nicely rounded off, but that's fine. We will probably not have too much of a problem then on that side. So then that times the 2.58 gives me plus minus 0.08937. Sure. Okay. So 0.4 minus that. Okay, my calculator is now going bonkers, so it is now thinking that is a very difficult calculation. So let's just do it over again. 0.4 minus 0.08937 gives me 0.3106, 0.31. So none of the others are, but and then if I say that 0.4 plus that, I will get the 0.49. So E is definitely the right answer. I think the important one was that we worked with a 2,58. If we used the wrong one there, just want to check if there was an answer. So if we used 1,96 there, we would have gotten that one as A as the answer. So again, important, we're talking about 99% confidence interval. So for 99% confidence interval, the Z is equal to 2,58. Okay, let's go into the next one. So now we've done confidence interval as well. So then the next thing is hypothesis testing. Okay, so let's look at all of this. Okay, so let's quickly first incorrect. So let's look at what all the things that they ask. The government wants to procure low-end smartphones for COVID community health workers. A government official wants your assistance in testing the hypothesis that the average cost of a low-end smartphone is more than that. The following additional has been put together. So N is that, where's that, where's that. Okay, more than. More than is a one tail. We're looking for incorrect one. Okay, that's correct. So let's write. So they're testing that. So your null hypothesis is that your alternative is that. And I think, like we discussed on the chat today, or on the WhatsApp group this morning, if I said to me the critical value at 2.5%, it would have been 1,96, because that alpha was 0,05. But and that is nearly correctly showed this morning, because they don't tell me exactly that I'm looking at the 2.5%, I'm using the 0,05. And at the 0,05, so that is 95%, what is my critical value for a one tail? So at 95%, and again, I go back to that table, for 95%, critical value is 1,645. If they told me here, like in that example that was shown, 2.5%, then they've already taken into account that I'm working with a one tail, and then it would have been 1,96. But because we then assume we're working with that, it is 95%, but then one tail, it should be 1,645. So A is the incorrect answer. So what else? Quickly run through it. So that we need to calculate. We can do that now so that you have that as well. The null hypothesis is that the average cost of a low-end cell phone is equal to, so we've done that. So that is correct. So still need to calculate that one. There is a 5% level of significance. Yes, there is. They told us that. So that is correct. So let's work out the t-stat. Okay, so the t-statistic is where z is equal to x minus mu. So like we would have done in some of the previous work. So let me quickly, standard deviation is 800. N, where's n is 100. So the square root of n. Okay, so basically 1,200 minus 1,000 is 200. 800 divided by, remember, square root of 100 is 10. So 800 divided by 10 is 80. So 200 divided by 80. Let's quickly, 200 divided by 80 gives me 2.5. Okay, which is that one. So again, that one I just showed was also correct. So just to the point of this morning on the WhatsApp chat as well, if I told you what is the critical value at 2.5%, then it would have been 1,96 because of the one tail. They haven't told us, so we're working with the alpha 0,05, working with the alpha of 0,05 at the one tail out of the study guide, then your critical value must be equal to 1,645. And that's why option A in this instance was the wrong one. Okay, so now, and again, interesting. So there was 5 options. Now suddenly there's 4 options, 5 options. So sometimes we don't complain when there's 4 options. So let's look at a two-sided hypothesis test. Okay, so two-tail for the mean with a known population standard deviation. So we know then that we're working with a Z. We know it is two-sided. So here will be a part of a p-value. Here will be a part of a p-value. Yields a p-value of 0,03. Okay, so the p-value equal to 0,03. So let's see, incorrect one. The null hypothesis is rejected at a 5% level of significance. A ZT is appropriate. Okay, that's the easier one. We did identify that the Z was appropriate. The null associated T-stat is that, so we'll check. The null hypothesis is not rejected at a 1% level of significance. Okay, so let's just, as I've written in reject, accept. Okay. So if they tell me the p-value is 0,03, how big is that area and how big is that area? What would you have said? Okay, anyone? Okay, so that is the trick question in this paper nearly. Okay, because if you, okay, so what the null hypothesis rejected at the 5% level of significance. The null hypothesis not rejected at the 1% level of significance. Okay, so we will get to work out, okay, they don't tell us enough of others, so we will need to work with that and that. If they don't give us enough information, okay, so they don't tell me what the Z is, they tell me the p-value. Okay, so 0,03 is smaller than 0,05. So let's draw this a bit different. So we have that point, but let's draw it a bit different for you guys. That was So let's say it's something like that. Okay. So okay, so that is that. That is that. So 0,03 will be smaller than the 0,05. So we will reject the null hypothesis. Okay, correct. Then we put in if that is still smaller than the red part. So that is smaller than, so when we say the same here, we accept, we reject. So at the 0,03, the red part is bigger than the green part, so we do not reject because we accept, so that is also correct. So now that was the only one that is wrong, but let's see what that should be. So what would you have said that answer should be? Okay, so to see if I can. So that part would have been the 0,03, 0,97, 0,97, okay, 1,88. And look at what that answer was, 1,885. So we would have said, oh, but at that 0,3, that would have been correct. Okay, so the reason why is because that value, because we're working with a two-sided, that total would have been equal to 0,03. So the value that we are working out here should actually be 0,03 divided by 2. So the Z that we are going to get should be 0,03 divided by 2. So 0,015. So 1 minus, instead of 1 minus 0,03, 1 minus 0,015. So we're actually looking for the Z of the 0,985. So 0,985 would have given me 2,17. So the actual value that it should have been here is 2,17. So that is also why that one is wrong. It should have been, and let's do that. So two-tail, that part is my p-value. So the two of them together is 0,03. So to work out the t, the z, why am I now? The z, I need to divide that by 2, and then I can go to the table and to get my z. When we look at rejection or acceptance, we look purely at the p-value, because the p-value is what we will evaluate it against. But when we want to now get to that z value, we will need to remember, okay, but my p-value is actually split because I'm looking at a two-tail. So to get that physical Z value, it won't be 1,885, it will be 2,17. Okay, so this was actually a very difficult one, but I nearly eliminated that. We didn't need to work that out with nearly making it simpler for myself. And by this reasoning, nearly did that without nearly going to that part. Okay, so 1, 2, 3, 4. So it's past 10, but let's quickly see if we can get the rest of the answers. Okay, this one's supposed to be simple, degrees of freedom. So we're working with a chi-square, even though they're not telling us it. So chi-square, degrees of freedom, C minus 1, row minus 1. So column minus 1. How many columns? 1, 2. So 2 minus 1. How many rows? 1, 2. 2 minus 1. So 2 minus 1 is 1. 2 minus 1 is 1. So 1 times 1 is 1. And our right answer is 1. Degrees of freedom is a nice one. Just remember, you don't take the total into account when you work with chi-square. So that is not a variable. So it was home and away. So 2 minus 1, secure, insecure, 2 minus 1. Oh, on the same table. Okay, so a lot of things that we've been doing today, we're referring to the table. So we know the degrees of freedom was 1. So assume a 1% level of significance. So 1% level, 0,01, that's 1%. So we will go to degrees of freedom. So let's just get to the chi-square, chi-square, chi-square. Okay. Degrees of freedom 1, 0,01, 0,01. So my answer must be 6,635. 0,01, degrees of freedom 1. What was it? 6,635. There's your option. Okay. So this one was checking that you can get the answers from a chi-square table. So we actually had now 2 questions on chi-square. That is actually fascinating. And another one. Consider the continuity table once again. Now that observed frequencies together with expected frequencies in brackets. Oh, they actually ask you to work this out. That is scary. What is the value of a chi-square test statistic? Sure. Okay. The following table shows the observed and the... Okay, so you now needed to work this out. Okay, so that is actually quite scary, but I am again going to say you need to work out the observed minus the expected square root of that divided by the expected. Okay, so what I normally do with this, and let's do that, I will again use Excel and I will send this to you as well, that you can nearly use it in the exam if I ask it. Okay, so that is my observed that is my expected. Observed is 58, it is 18, it's 15, it's 29. The expected was 29.68, 26.32. Yeah, this is not a nice one if you get this in the exam, but use this template actually then, because now the formula says, so what I'm just going to do is program it in here. So it says my observed minus my expected to the power of 2 divided by the expected. Okay, and then I need to sum all of that together. So this formula is actually now working that out. So that's why I love Excel. So actually very simple for me to use it. So please, this was chi-square. So I'm just making that you can use it. This one was a standard deviation. Okay. So that you can use it in the exam as well. So 11.278. Where was that? 11.278. Okay, so otherwise you would have needed to say physically on your somewhere on a table, you would have needed to write it out, or on your calculator, that minus that to the power of 2 divided by the expected to get that answer. The same, that minus that to the power of 2 divided by expected to get that. Same there, the same there, and then you need to add everything together. So please, if I do give this for you in the exam, please use my Excel that I will send to you. Okay, because I don't want you to do that calculation. It just will take again so much time for you. So nearly try to avoid that. Huh. Okay, so here an occupant of more lasagna would like to use simple linear regression model. The following summary measures were calculated from sample of 30, where y as sales and x as foot traffic. Calculate the slope. Oof. Okay. Now I'm actually caught off guard here because you need that formula that was in the formula pack and I don't have it now. I will do this today, write it down for you, and send it on the group, because what is that formula? Let me quickly check if I have that formula somewhere. Where would it be now? No, I'll rather let me write this out the whole way, and I even check if I can maybe simplify it for you in a spreadsheet that maybe, but let me see if I can do something for you. I don't know this formula off by heart at all, so this would have thrown me in the exam if I didn't have the formula page with me. So let me just, I need to go and check what that is. Okay. I to be honest, I don't know what that what that formula is to get B1, so I just need to go and look. Okay, the last one is on nearly asking you a bit of definition in here. So when there is no foot traffic in the store, so they give us a formula, i.e. foot traffic is 0 and store only sells online, sales are estimated at that. Okay, so note it's thousands of rand. So if X is 0, your sales will be 6.64, but remember it is in thousands. So if you multiply that by 1,000, that will be correct. So if X is 0, it will be 6.64, but you need to multiply by 1,000 because it's thousands in rand. So option 1 is correct. 78% of a variation in sales is explained by the variation in foot traffic. Okay, so the variation should be 0.6099. What could have happened is if you calculated R, you would get 0.7810, but R is not explaining the variation. Remember, that is the coefficient of correlation, coefficient of variation. So that explains the variation. R would have explained the correlation, and that's the 2. So if you did say the square root of that, you would have gotten that answer, but we want variation and not correlation. So that is the wrong one. So look at that. There is a positive linear relationship. How we identify positive is to look at the slope of x. So the slope is positive, then your relationship will be positive. If it was minus, then your relationship will be negative. So that is the link between the two. So positive relationship because you've got a positive slope. The coefficient of correlation is that, yes, it is, because I just said if you take square root of that, it works it out. So that would have been D. Okay, so that is how we would have calculated that one. Okay, and that was the whole mock exam. I will go and recreate for you nearly that one can work it out. I just need to look for that formula, and then I'll submit it on the WhatsApp group. I am now, yeah, I actually don't know what that formula is now, and then I'll also write it into the Excel, that if you get these numbers in the exam, the similar kind of question, you can basically just change it in the Excel and can maybe work it out. Okay, that is it for today, guys. That was a quick run through for the mock exam. I'll get that we upload this in the next hour or so, that you can listen to it again. So let me even stop now, and when I can start